try doing some of these. And it is going to be slightly difficult, but that's part of the game, right? It says, now this question says, find the equation of the tangent, okay? Find the equation of a tangent. The tangent line is always going to be linear. Y equals mx plus b. You see this m? That's our slope. That's our IROC, okay? Once we find our y prime, our slope function, we're going to plug the x value in there, and that'll give us m. To find b, we're just going to plug the x value as 0.5, the y value as -1. So before we worry about that, let's try and find the derivative of this function. 2x is simple. I'll give you 2x. 2x is simply going to be a 2. You drop the x. What about -1 over x? We're going to use the power rule. -1x. So what we're going to do.
Power of 2? -2?
Yeah, I think that's it. It's just going to be this, right? Because there's a negative, so it's going to be -1, x -2. So now we're going to plug 0.5 in there as x. So again, if you want to rewrite this, you can throw it back on the denominator like that. So you have 2 plus 1 over 0.5 squared. That's 0.25. That's 4. It's going to be 6. So that's our slope. Y equals 6x plus b. How do we find the b value? Notice they've given us a point.
So you just plug it in?
Yep. You simply plug in the point. So you're going to plug -1 as y, and you're going to plug x as 0.5. So this will give you 3 plus b equals -1. So b is -4. So therefore your equation is 6x plus 4, the equation of the tangent line, okay? And you're done. Easy peasy. It will get difficult though. I mean, how difficult could it possibly get? Let's try this one. How do you think we go about finding y prime for this? It needs to be in a certain form, right? Right now it's not in the power rule form. So we need to change this from a radical into exponential.
Is it 3x to the power of 3 over 2?
3x, like that. Close. But it's not. It's like this. Notice the difference. This versus 3x cubed to the power of 1 over 2. It's like this. And if you want to open the brackets, you can. So what you missed is the fact that the 1 over 2 exponent also applies to the 3. So it should be 3 to the power of 1 over 2 and x to the power of 3 over 2. That's our y.
Okay.
And now we're going to find y prime. In fact, 3 to the power of 1 over 2, you can just write that as √3. That's going to be your a value. And we're going to bring the 3 over 2 down. What's 3 over 2 minus 1? Three over 2 is 1.5, right? 1.5 take away 1, you get a half. And there you go. That's our y prime. And to find the slope, we're just going to plug 3 in there. So √3 times 3 over 2 times √3. What is √3 times √3? It is √3 squared, right? What's √3 squared? This is just a logic question. You don't need a calculator if you know the rule. √3 squared.
Is it √9?
Yeah, it is. It's just a 3. In other words, you can think of it like if you have a square root and a square, they cancel each other out. So √3 times √3 is simply a 3. And then we have 3 times 3 over 2. The answer is 9 over 2 for the slope. Cool? And then we can find the equation. So that's going to be our m. Y equals 9 over 2x plus b. To find b, we're going to plug both of these guys. So 9 equals 9 over 2 times 3 plus b. So this becomes 9 minus 27 over 2. You can multiply this by a 2 LCD. So we have 18 minus 27. So it's negative 9 over 2 is your b value. Therefore, your equation is 9 over 2x minus 9 over 2. And you are done. Okay?
Uh-huh.
Fun. Let's try doing this one. It's going to be similar. Well, there's a root, that's the similarity. This is not in the right form. We have two different things, completely different things multiplying into one another. What do we do? There's only one thing you can do. It's not in the right form.
Do you FOIL the brackets?
Yes, you do. What's the first term? If you FOIL it, okay, you're gonna go this way first. So what's that times that?
Square root of 3x.
What happened there? Wait. It's not that. I think that's wrong. Square root of 3x. It's gonna be like this: x times 3 root x, right? Look at this. We have x root x times root x. Whenever you have the same two roots multiplying into each other, the root it dies out. We can kill the roots. Okay. So root x times root x is simply an x. So you'll get a 3x like that. The next term will be a root x. There's nothing to simplify there. The next term, what's negative 2 times 3 root x? Negative 2 times 3 root x.
Is it negative 6 root x?
Yeah, negative 6 root x. What's the last term?
Negative 16?
Yeah, negative 16. These are like terms, right? 8 apples minus 6 apples. It'll be 2 root x minus 16. This so far is only y. Now we're going to find y prime. If you find y prime, 3x, the x is going to drop. 16 is just going to disappear. Then from here we get 2 times 1 over 2 times x to the power of half minus 1 is negative half, like that. So you get 3 plus x to the power negative half. If you throw that in the denominator, you get 3 plus root x, like that. Okay?
Uh-huh.
What do you get if you put x as 4? If you plug x as 4, what do you get?
3 plus 1 over 4?
Right. 3 plus 1 over root 4. Okay, so 3 plus 1 over root 4, which is 3 plus 1 over 2. What's 3 plus 1 over 2? No?
Is it 7 over 2?
Yeah, it is. And there you go, that's your slope. To find your other thingamajig, we know our slope is 7 over 2x. It's mx plus b. We're going to plug y as 0. We're going to plug x as 4, like that. Okay, 2 goes into 4 twice, so b is negative 14, and you're done. Is this difficult?
Mm-mm.
It's just a lot of roots, right? I think that's the issue, because there's so many roots. If you just remember the root laws, it's not super bad. The main one is, again, it's this one. If you have root a times root a, it's just a. The root kind of dies out. Now, for this question, it is not even close to being in the right form. What you do is you split them apart. That's the only thing you can do, right?
Mm-hmm.
X, I can rewrite that as x to the power of 1 over 2. How do we rewrite the denominator if I want to write that in exponential form?
X to the power of 1 over 3?
Yeah. Same thing here. We're going to split them apart. And now I'm going to move both of them up. If you move the other guy up, you get x to the power of negative 1 over 3. Yeah.
Mm-hmm.
If you move this guy up, what do you get?
Does it turn into a negative?
Yeah, you'll get x to the power of 1 over 2 minus 1 over 3. You can do that, or I know what you mean. Like this, if you move it up, it will become a negative. They have the same bases. You can add the exponent, so it'll be 1 over 2 plus negative 1 over 3. Okay, so 1 divided by 2 minus 1 divided by 3 is 1 over 6. So there we go. And from here, it's easy. You bring the 1 over 6 down, you take away 1 from it, you'll get negative 5 over 6. Same thing here. You bring the negative 1 over 3 down, you take 1 away from it, you get next to the negative 4 over 3 like that. If we want to clean this up, this will be 1 over 6 times x to the power of 5 over 6 plus 2 over 3, x to the power of 4 over 3 like that. If you plug 1 in here, anything to the power of 1 is 1. So the answer is simply the slope is 1 over 6 plus 2 over 3. We'll multiply this by 2, so you get 1 plus 4, 5 over 6 is your slope. Cool?
Mm-hmm.
And then to find the mx plus b thingamajig, 5 over 6x plus b, y is negative 1, x is 1. So it'll be negative 1 minus 5 over 6 will be b, that's negative 7 over 6. And you are done with the question. So if you can't use a power rule, that probably means you have to do something to it. And this is one of the things that you can do. Okay?
Uh-huh.
Do you understand why we splitted them?
Because you couldn't do anything else?
That's exactly right. The only way to put this in the right form would be to split them apart. Otherwise, you can't do the thing. And we are done. I can just move away from these roots and whatnot. I'm going to show you some rules. Is there a question here? All right, there's a question. So now let's look at this. It's similar question. The way we've been doing it, like especially this question, we have to FOIL it, right? Because it is not in the right form. But foiling can be tedious, especially if there's multiple terms in it. This one isn't so bad, but you could have something with like 6, 7 terms in it, and then it's gonna become super tedious. Instead of doing all of that, okay, what you could do is something called the product rule. Notice in this question, we have two different functions. One of them is a power 5 function, yeah, on the right.
Uh-huh.
And the other one is, what's the other function? It's a quadratic, no?
Mm-hmm.
So we have a power 5 function and we have a quadratic. So what you do is, instead of foiling it, you could use the product rule. And the product rule looks like this. Let's do a quick, easier question first. Let's say you have 2x times x squared, okay? I know this is 2x cubed. We can FOIL it and do it that way. But the product rule says this. The derivative of this is going to be the derivative of the first guy. We can call this f. We can call this g. It'll be the derivative of the first guy times the second guy as it is, plus the first guy as it is, times the derivative of the second guy. So look at this. In this case, y prime, we're looking for, this is the formula for product rule. What is f prime? If f is 2x, what's f prime?
2.
Yeah, 2 times the second guy as it is, x squared, plus f as it is, 2x, times the derivative of g. What's the derivative of g?
2x.
Yeah. So you get 2x squared plus 4x squared. The answer is 6x squared. So this is the product rule, okay?
Mm-hmm.
we're going to use the same idea here. This is going to be our f, this is going to be our g, and the formula is f prime g plus f g prime. So tell me, what is the derivative of h prime of x? So we're first looking at the x squared minus the f. So basically we're looking for f prime here right now.
2x minus 3.
Yeah, that's perfect. Times what?
All of g.
All of g as it is. And then plus what is happening here? What's this other thing?
It's all of f.
Yeah, all of f, x squared minus 3x times what?
4x to the 5x to the power of 4. And that's it.
Right. 5x4, right? Yeah, and that's it. You're right. And we are done. Easy. It's way quicker than foiling it, right? Would you agree? Because foiling it is not very fun. This very powerful method. And that's it for this question. Just remember the power rule exists. They foiled it, but we don't have to foil it. Let's try another one. Same idea. If you see, and when do you use the power rule? Power rule you'll use if you have f and g, right? If you have something like f and something like g, you're gonna use the power rule, okay? Can we use the power rule for this question?
Yes.
Right, we can. So tell me, what's the derivative of h prime of x?
15x squared plus 14x.
15x squared plus 14x, yeah? That's the first guy's derivative, f prime. Now you write the second guy as it is. What about the other two? What's the second half of this?
You write f.
Yeah, you write f as it is. What's h prime? Oh, sorry, g prime.
4x plus 1.
4x plus 1, perfect. And there we go, right? Now,
Mhm.
you can see why the power rule is so powerful, because if you go about foiling this, you'll get 9 different terms, and no one wants to deal with 9 different terms. There's a lot of room for error, right?
Uh-huh.
No one likes that thingamajig. So, and there we go, we're done. Easy as that. Oh, you're not gonna like this. What if there's 3 different terms though? Oh, that didn't come up, but let's just do a quick example of 3 different terms. Let's say you have x squared, x squared, and x cubed. Now we have 3 different terms, right? What you do is you're gonna either take this as your f and this as your g, okay?
Mhm.
And or you can say this is your f and this is your g. Which one would you like? Doesn't, honestly, it doesn't really matter. I'm gonna go with this one, f and g. Now look at this. X, yeah, we'll do it the long way. We'll do it the long way. Look at this. So what does the product rule says? It says the derivative of f times g plus f times the derivative of g, correct?
Mhm.
Now this, we need to find the derivative of f prime. Well, f prime, the function f itself comes with 2 different functions, right? It comes with x and x squared. So what you need to do, this is gonna be like a staircase kind of a question. It's a product rule within a product rule. We first need to use product rule to find f prime. Okay, so look at this. F prime will be the derivative of the first guy times the second guy as it is, plus the first guy as it is times the derivative of the second guy. So that gives us x squared plus 2x squared. That's going to be 3x squared. And that is our f prime. Cool?
Mm-hmm.
So f prime is going to be 3x squared times g as it is plus f as it is times g prime. What will be g prime?
3x squared.
Yeah, and you're done. So you could have three terms. In that case, you need to split them apart, and it's going to be like a chain question. Okay?
Mm-hmm.
It hasn't come up yet, but I'm sure it will. Oh, yeah, it's here, but they didn't give us a question. This one, can we use product rule?
No.
No, you can't, right? Because you only have one guy here. So this one is the normal power rule question. When you bring the power down, the 6 all the way down, so you get a 6 here. And the bracket stays as it is. Doesn't change. You take 1 away from it, becomes a 5 up top. But you have a quadratic inside of an x power 6 function. You see that?
Mm-hmm.
So when this happens, when you have a different function within one another, you need to use the chain rule. The notation, maybe you like this. Let's say you have y is, there's an f of x inside, okay? And then on the outside, we have the function g, okay? Like here, our g of x would be x to the power 6. Our f of x will be the guy on the inside. So the chain rule says the derivative of this y prime will be g prime of x times f prime of x. So you do the normal power rule stuff that you do, but then at the end, you're going to have to multiply this by the derivative of the bracket, the derivative of the inner function. What's the derivative of the inner function?
2x plus 3.
Right, 2x plus 3. And you are done. Cool?
Mm-hmm.
So that's the chain rule question. Let's see if we have anything else. This one is weird. We did this using the whatever method, right? The x plus h, whatever we were doing back in the day,
Mm-hmm.
which is super annoying. To do that, you need to find the LCDs and you need to clean things up, and there is a lot of room for error, right?
Mm-hmm.
Can we use the power rule here? What do you think? Can we use the power rule here?
Yes.
You can use the power rule. We have two different things multiplying each other.
Oh, you can't?
You can't, because well, you could if you really wanted to. You can actually. The technical answer, I'm gonna tell you the technical answer. Yes, you can. What you need to do is you need to bring the 3x minus 1 upstairs. If you bring that upstairs, what do you get?
Negative 3x.
No. Only the exponent is negative, like this, right?
Oh, okay.
The actual term does not change. It's the exponent that changes. So, and now we're gonna use the thing as we do, our power rule, okay?
Mm-hmm.
So our power, not our power rule, sorry, our product rule, because we have two different things multiplying. Now we're definitely multiplying them into one another. So our thingy says it'll be the derivative of the first guy. What's the derivative of 2x plus 5?
It's 2.
Yeah, it's 2 times the second guy as it is, okay, like this,
Mm-hmm.
plus the first guy as it is, times the derivative of the second guy. What's the derivative of the second guy?
3.
No, it's not. You see, this is a trick question because notice there's a -1 exponent up top. The
Uh-huh.
derivative of the second guy is not 3. It is going to be, the -1 is going to come in the front, okay, like this, times 3x minus 1 to the power of -2. You see that?
Uh-huh.
It would have been 3 if this was a power of 1, but it's not. It's -1. It's in the denominator. This is like a denominator question. So you got to treat it as such, as like a power rule. It's not going to be 3. But then you also need to take into account the chain rule, because we have a linear function to the power of a negative function, right? So we
Mm-hmm.
have a linear inside a irrational. So what you need to do now that we found the power rule answer, you need to multiply this by the derivative of the bracket. What's the derivative of the bracket?
It's 3.
Yeah, and there you go. That's going to be the final answer for this question. This is the shortcut way of doing it, actually. No one wants to do the x plus h thing, right? This is
Mm-hmm.
way, way quicker, and that's how you would do it. But there's another way to do that same question, which I'll show you, I think, next. Actually, no, it's not here yet, but you can use the product rule to do, actually, what did they do? Yeah, they did what we did, right? Yeah, exactly. We left up until this point, but they cleaned it up. Doesn't matter. There's another formula to do this, which we'll see in a little bit. This is something over something. A rule for this exists. It's called the quotient rule. It's very, very similar to the product rule with one slight difference. The slight difference being instead of a plus in the middle, there's a minus. And we'll get to it when we see it. Let's look at this question though. So we have some object, and by the way, this is used a lot in calculus. This is derivatives used a lot in physics. So there's an object moving. We don't actually have to worry too much about the physics. We're just going to focus on the math, but I will tell you what's actually going on. Straight line. So we have, you see, this is, what's the power of this function?
4.
It is not 4. What's the degree of this function? I guess that'll be the question.
3.
It is 5. This is a quintic function. This is t power 5 function, because if you open this, you get a t4, right? And then when you FOIL it, you're going to get a minus 3t5 term. See that, t5?
Mm-hmm.
So you need to take into account, like, what if I asked you, like, what's the degree of this question? What is the degree?
2.
Yeah, exactly. What if there wasn't a squared here? What's the degree now?
A 3.
Yeah, it's the same thing. This is a degree 5 function. And it's gonna be positive or negative. That's a trick question. What do you think? Is the leading coefficient positive or negative?
Positive.
Yeah, actually, it's because we have -3, but then we're taking it to the power of 4. Anything squared or power 4 or 6 or 8, they will always end up becoming positive. So the graph of this looks something like this. Yeah, it's gonna look exactly like this. This is on the y-axis, we have his position, right? You can even think of this like this is the water, okay? He starts from underneath the water, he comes up, and then he goes up, okay? Like a
Mm-hmm.
bird, I guess. This could be like the trajectory for like a bird. Like what's a good hunting bird? Something that's gone underwater to catch a fish and then flies back up into the sky. Something like that. So on the x-axis, this is the water, okay? But on the x-axis, we have time in seconds. On the y-axis, we have position in what? Centimeters. So what the question is asking you, determine the object's velocity. How is velocity related to position, if you know? How are velocity and position related? velocity is simply speed, right? Speed is the rate of change of position. If you think about it, speed is kilometers per hour. Rate of change means rise over run, right? Slope.
Mm-hmm.
We have kilometers on the y rising. We have time, hours on the x on the run. So velocity is simply the slope of the position function. In other words, more importantly, it's the derivative. All you have to do once you have the s, the position, you just find its derivative and that'll give you velocity. Cool.
Uh-huh.
So what this question is asking you is to find the velocity at t equals 2. So it just wants you to find s prime of 2. That is all what it wants. So to find that, let's first find s prime. We have to use the product rule here because we have two different things multiplying into one another. Tell me, how do you do this? Use the product rule to find the derivative. Product rule says what? F prime, right? Look at this here. T is your f. And this other power 4 function is your g, okay?
Mm-hmm.
So we need to find f prime. If f is t, what's f prime? What's the derivative of t?
1
1, yeah. Times the second guy as it is.
times t.
Plus, here. This is good so far. This is f prime, this is g, okay? Yeah,
Mm-hmm.
the chain rule is going to come in the second part. Plus f as it is times the derivative of g. What's the derivative of g? G is 6 minus 3t to the power of 4. Use the power rule. No? 4 comes down, right? It'll be
Mm-hmm.
times 4 times the bracket as it is to the power of 3. But now the chain rule. What do we multiply this by? It'll be the derivative of the bracket. What's the derivative of the bracket?
1 minus 3.
No. So the derivative of the bracket is basically the derivative of 6 is nothing, 0. The derivative of minus 3t is minus 3. So that's going to be the chain rule component. You see this minus 3.
Okay.
And that's our s prime. It's a weird looking function. What does that simplify to? So 1 times something to the power of 4 is just that. 6 minus 3t to the power of 4 minus 4 times 3, negative 12t, and 6 minus 3t cubed. There you go. That's our s prime. And we want to find the velocity at t equals 2. You just plug, you see all the t's here,
Mm-hmm.
here, and here. You're simply going to replace all of them with a 2. Cool?
Uh-huh.
I think it's going to be 0 because there's a turning point, but I can double check. I'm going to plug t as 0 to the power of 4 minus 12 times 2 times 6 minus 3 times 2 to the power of 3. Yeah, it's 0. So the slope is 0. And you can see if you draw a tangent at 2, it's going to be horizontal as well. So that means the speed is 0. The velocity is 0. It is not moving at this time. When time is 2 seconds, the object is not moving. And that's the end of that question. Here, let's just quickly shoehorn in the idea of the product rule. Because it's not that bad, but you'll feel much comfortable after a couple more questions. So again, this is the product rule. Y prime is f prime g. The first guy is always f. The second guy is always g. So f prime g plus f g prime. For b, what's the first term here? What's f prime?
6x.
Yeah, 6x times the second guy as it is, plus the first guy as it is, times the derivative of the second guy. Now look at this derivative of the second guy. We're going to use a power rule normally, 5, 3 plus x cubed to the power of 4 times, okay, times, we need to find the derivative of the bracket. Okay, this is the chain rule component. And the derivative of the bracket 3 is 0, but x cubed would be 3x squared. And there we go. We are done. Same idea here, okay? Help me. What's f prime?
2x.
Yes. Times the second guy as it is, plus the first guy. No, it's not 2x. Oof. You know why it's not 2x? Because there's a 4 here, you see?
So you bring the 4 down?
Yeah, you're going to bring the 4 down. It's going to be 4x squared minus 9, 3 times, what's the chain rule component of f prime? See this guy? We need to multiply this by the derivative of the bracket. What's the derivative of the bracket?
2x.
Yeah, there you go. That's the chain rule component plus, or actually that's just f prime so far. We need to multiply this with g plus f as it is, so x squared minus 9 to the power of 4 times, what's the derivative of g?
2.
No, it's not 2. It's not 2 because there's a cube there, you see? It is not going to be 2. This one takes the priority. So you gotta use the power rule here. That's gonna be 3. That's gonna come down.
Mm-hmm.
2x minus 1 squared. And then the chain rule component. You need to multiply this with the derivative of the bracket, which is a 2. And you're done. Okay, let's do a couple of more. It's okay if you're not super comfortable with it. Again, our f is x cubed, our g is the 3x squared, whatever. So y prime, the derivative of the first guy, 3x squared, times the second guy as it is. So 3x plus 7 squared, plus the first guy as it is, f. Tell me what's g prime here, and take into account the chain rule.
You bring the 2 down?
Yeah. And what's the chain rule component?
3.
Yeah. And that's it. And you can plug this 2 in a calculator. We don't care about that. Here, I'm going to show you a difficult question. It's actually not difficult, especially if you remember, yeah, there's a bunch of ways to do this. What you can do is you can throw in the x, and that'll make life so much more easier. Because right now we have 3 different things, so we need to take this as f, we need to take that as g. You can do the double product rule thing that we did earlier, but that is tedious. What you can do is you can just straight up throw the x in first. So we actually have only 2 functions that we're dealing with. You can also throw this in with this by using a difference of squares. That might actually be even easier. If you use a difference of squares, what do you get between this one and this one? You see it's in the right form. It's a minus b, a plus b. What is the difference of squares formula? A minus b, a plus b becomes a squared minus b squared. Right? You remember this?
Mm-hmm.
So a is 5x, so we'll have a squared, which is 25x squared, minus 4, like that. And actually, you can now even throw this in there, which will make things even more easier, because this is way easier to differentiate than this one. Right?
Uh-huh.
So what we did was we just cleaned it up using some rules that we've learned before to make our life a little bit more easier. What's the derivative of 25x cubed minus 4x? You're going to bring the 3 down.
50x squared.
So it'll be 75x squared minus 4. And you're done.
Okay.
25 times 3 is 75. Right?
Uh-huh.
Are you having fun?
Sure.
All right, this is what I was trying to tell you earlier. There's a rule when you have something over something. You can absolutely use the power rule to bring it up. but then you're going to be dealing with negative exponents, which is a little bit annoying. Here's what you do. If you have f over g in this form, the derivative y prime will be similar to last time, f prime g, but instead of a plus, you have minus f g prime. But then there's one more element to this. It's going to be all over the original function g squared. Okay?
Mhm.
Here, let me do this one. So f prime, f is the numerator, g is the denominator. 3x minus 4 f prime will simply be a 3 times g is the denominator as it is, minus, now it's minus because this is the quotient rule. F as it is, so that'll be 3x minus 4 times what's g prime?
It's just 2x.
Yeah, and all over g squared, okay? So x
Mhm.
squared plus 5 squared, and you are done. And that's it, that's the quotient rule. The only difference from the product rule is now we're dividing by g squared, and instead of a plus, there's a minus. And we're dividing by g squared because when you take the g up, it becomes to the power of -2. That's why when you bring it down, it becomes g squared. Okay. Let's try this one. Is this a product rule question or a quotient rule?
Quotient rule.
Yes, again, f prime g, derivative of the first guy times the second guy as it is, minus f g prime all over g squared. Whereas our product rule was f times g is f prime g plus f g prime. All right, tell me, what's y prime? We're just gonna follow the formula here. The first term is gonna be f prime, right?
So 2.
2, yeah. What do we multiply this by? G, as it is, no
Mhm.
change. Minus, what about the next term?
2x
And then, what do we multiply 2x by?
by another 2x.
Yep, yippity. And then what about in the denominator? We have the original g squared.
Square.
And you are done. One and done, easy, right?
Mhm.
Alternatively, if you're feeling brave, let's say one night you can't sleep, what you can do is you can go the other route. You can use this formula to find, I wouldn't advise it, but you can use this to find the exact same thing, which is gonna be super tedious. Why is it gonna be tedious? Because in the denominator now you have something super wacky. You're gonna have 2x plus h, but on the bottom you're gonna have x plus h whole squared plus 1 minus this. And when you go to take the LCD between this and this is both of them multiplied to one another. So what ends up happening is you need to multiply the 2x by x plus h squared plus 1. And you need to multiply this guy by x squared plus 1. It's gonna get rough pretty quickly. So yeah, but hey, if you're feeling brave, this is the way to go. Alternatively, this way. Quotient rule, 2 steps, and you are done. Let's try another one. Again, this is a quotient rule problem, right? Because you have f over g, so it comes f prime g plus f g prime. What is f prime?
It's 2.
Yeah, straight up 2 times the second guy as it is, plus the first guy as it is, and now be careful, what's f g prime?
1/2 times x.
Close, but so we have x to the power of 1/2. It'll be 1/2 times x to the power of, you need to take away a 1. It'll be minus half, like that. So it'll be 1/2 times x to the power negative 1/2, all over what? All over g squared. If g is root x, what's g squared? We did this earlier, remember? If you have root x times root x, this is the same thing as
It's just
saying
x.
it's just x. Yeah, and there we go, 2 steps. Again, if you're feeling brave, you can go the x plus h route. In fact, some teachers are super, I don't know, like they want to test you. Like mean was the word I was looking for. What they're gonna do is they're gonna give you this exact same question, but they're gonna tell you that you can't use the quotient rule. Or they're gonna tell you you have to do it by first principles or the limit the x plus h way. And that one's gonna be fun. It is possible to do it. If you do it that way, you need to rationalize the numerator, which is tedious, but we don't care about that way here. So there you go. That's literally the quotient rule. Super simple. Let me find, oh my God. You're not gonna like this. Question to you. Which rule do we use here? Any ideas whatsoever?
Um,
This is a trick question. What you do is you're gonna have to use both the product rule as well as the quotient rule, because you're gonna see this is gonna be a little bit weird. Because on the numerator and the denominator, we have two different things multiplying. So locally, we're using the product rule, but the big picture overall, we're using the quotient rule. So you're gonna have to use both of them, which is gonna be a little bit annoying, but it's okay, we got this. We're gonna do this one by one, okay? I'm gonna first focus on finding the derivative of the numerator. We can call this, this is f, this is g. If that's f, what's f prime? F is the whole numerator. How do we go about finding the derivative of the numerator? In other words, let's just ignore the whole question. Let's like simplify it. This is f, okay? Or this is y, you can even call it y. How do we find y prime? Which rule do we use? You see there's two things being multiplied into one another, right?
mhm.
It's a product rule. And product rule says the derivative of the first guy, what's the derivative of x plus 1?
It's 1.
Yeah, it's 1. So it just kind of times the second guy as it is, plus the first guy as it is, times the derivative of the second one, which is also a 1. So actually you can combine these two. This is going to become, f prime will become 2x plus 3. See that x plus x, 2x, 2 plus 1, 3. Similarly, we're going to do the same thing in the denominator, and you'll see that it's not that difficult. X minus 1, x minus 2, right?
Mhm.
So tell me what's y prime if this is y.
It's 1.
It's 1 times x minus 2 plus x minus 1 times 1, right? Like that.
Uh-huh.
Combine the like terms, you'll get 2x minus 3. Okay.
Mhm.
Now that we have our f primes and g primes, we're just going to plug it into our formula up there, the quotient rule formula, this one. So it'll be y prime will be f prime times g, f prime we just found it, 2x plus 3 times g, g is the entire denominator as it is, minus f, which is the entire numerator as it is, times g prime, which we found here earlier, 2x minus 3, and everything over g squared. So g is our original denominator. What we're going to do is we're going to square this entire thing, and there we go. That's going to be the answer to this question. A little bit annoying because, yeah, you have product rule locally, but on the bigger picture, we have a quotient rule. And this is how it's going to be actually, like every rule that we're using and learning, there will come a question where we kind of have to use all of them. It's not here yet, but we'll probably see it. Don't worry too much about it. Let me find. All right. Application. A is for application there. So there's a bunch of numbers, a bunch of words. We don't really care. It just says find the rate of change after 1 hour and after 2 hours. What are they asking us to find? What does rate of change mean? Rate of change is simply just the derivative, right? In fact, after 1 hour means they wanted to find at 1 hours. That will be IROC. So basically, we're just going to find the derivative, and then we're going to plug the x value as 1, and then we're done, basically. That's all we need to do. So to find the derivative, right now, it's if you can clean it up, I would always say clean it up before you find the derivative. It'll make your life easier later. So to clean this up, I'm just going to FOIL it. So 1000 times 1 is 1000, and 1000 times the other term will be 4000 t divided by t squared plus 50. So tell me, what's p prime of t? I need to find the derivative of this guy. Any ideas? Well, the derivative of 1000 is 0, so this one is gone, right? Over here, we're going to use the quotient rule. So 4000 t, quotient rule says f prime g minus f g prime over g squared. So if f is 4000 t, right, what's f prime?
1.
4000. You drop the letter, right?
Oh.
If it's 4x, it's going to be 4, same idea. Times the second guy as it is, so t squared plus 50, minus the first guy as it is, times the derivative of the second guy. What's the derivative of t squared plus 50?
2t.
Yeah, 2t. And all over this guy squared, right? Like that. See that? So what do they want? They want it at 1 hour. So we're just going to replace everything with a 1. All the t's with a 1. So this will be 51 minus 4000 times 2 all over 1 plus 50 squared, 51. So 4000 times 51 minus 4000 times 2 divided by 51 squared. So the rate of change for this bacteria is 75.36 at 1 hours. Now, what does that actually mean? It means at 1 hour, right, they're growing. The rate of growth of the bacteria is 75.36 bacteria per hour. Okay? 75.36 bacteria per hour. They go pretty quickly, actually. I mean, it depends on the strains, but some bacteria, they can go 9-fold within the hour. Some of them take a little bit more time. Have you ever done like those petri dish things in science?
Uh-huh.
Yeah, so you're actually looking at live bacteria, which is kind of fun. You've used a microscope, right?
Yeah.
Yeah, and we do count these. Counting them is not very fun, actually. You will do it if you haven't. Like, what you need to do is you need to count. Like you start off with 1, right? And then they're gonna give you a petri dish that's been sitting there for, I don't know, like a day, and then they'll give you the petri dish after 2 days, and they're gonna ask you, what's the rate of change of the bacteria population. So you literally do what we did, except they'll give you the numbers. So that one's actually easier because you just find rise over run for that one. If they give you a bunch of these though, let's say they give you 10 of these, maybe they won't do this in grade 9, but what you can do is you can plot a function, right? If you just collect the data, X will be your days, Y will be the bacteria count. You can literally come up with a function like this that will give you the rate of change of bacteria at any day, not just 10 days. But anyways, all right, let's call it a day there.
All right, thank you.
See ya.